So, very good evening to all. First of all, let me congratulate Ambuja Madam for organizing such a fantastic workshop. People coming from various places in India and also from various disciplines and giving wonderful lectures. Also, let me thank her for calling me for this lecture. So, what I am going to tell you is about modeling language using complex networks. Actually, complex network is one of the recently emerging fields of research. Modeling anything as a network has come into play since 2012 onwards. Many papers have been published and many influential books are being published. So we'll discuss in like this: what are complex networks and how a language is modeled using complex networks. So this is our agenda: a brief introduction to complex networks, representing language of networks and applications. You are familiar with networks, right? What networks you are familiar? Sure, like computer networks, World Wide Web, Internet, etc. Yes? Friendship network, etc. are familiar. So, networks whose structure is irregular, complex, and very often dynamically evolving in time, changing in time. These networks are called complex networks. And how do you represent complex networks is using graph theory. Many of you may have studied graph theory, at least know what is a graph. Yes. This is basically a graphical representation of a network. There will be some nodes, we call them vertices or nodes, and there will be edges. Edges will be representing some kind of relationship between the vertices. And there are many possibilities. The graph may have no direction, that is, edges may have no direction. An edge from point A to point B is same as an edge from point B to point A. It's called an undirected graph. Or maybe it may be directed. There may be directions in the graph, or again there may be weights associated with edges. So these are the major types. So anyway, we represent vertices by circles and edges by lines. You are all familiar with this basic notation of graph theory. And also we may have components. Component is a connected graph, subgraph, which is also maximal. So this is a component, this is a component, this is a component, and this is a component. Large networks occur in Internet, and this gives rise to many other networks. World Wide Web. What's the difference between World Wide Web and Internet? World Wide Web is a set of documents, but Internet is a network of computers. And also so Internet gives rise to many other databases and social networks. Social networks does not cover Facebook, etc. only, but very many other networks in which people interact with each other. So this is an example of a social media network, Facebook friendship networks. Given a person, he is connected to his friends, he is connected to his friends, and so on. So I can say the network may evolve over time, and in some networks, if you go to messages, there will only one-way communication, mutual communication, etc. So a Facebook network. So Facebook is an example of a complex network. Your friendship, you, your friends, and their friends. So individuals are nodes, and social ties or relationships are edges. And maybe links may be referred to many different attributes, just friendship or summer relationship or belonging to common institutions, etc. So two persons are linked if they belong to a common institution. This is one of the classical network called a karate club network. This network actually was taken by observing the behavior of members of a karate club and how they interact during a period of a few years. So here again, you can see some of the things here. One is, it is having two colors, right? And you can see that these colored people are more close to these, closer than these colored people. So, and also you can see that some persons are important, more important than others in a network. For example, here, one is more important because he is having so many ties. Similarly, 34 is more important because he is having so many ties. So, in a network, all nodes are not having equal importance. Some may be more important than others. So again, so many other networks comes in ecology. Neurons in the brain, you may be studying neural networks or something. You model by a neural network based on the neurons in the brain. And in if two proteins interact in molecular biology, they are connected by a link, etc., etc. So networks appear in a wide variety of areas, wide variety of fields, and modeling with the networks is a very important thing in wide variety of fields, starting from 2012 onwards. One of the famous books you may be able to read is Linked. It's a very simple introduction to networks and other things. This is, if two proteins are physically interacting, they are connected by a network, otherwise they are not connected. So many other networks in electric networks, road networks, everything is a network. Again, citation networks. If somebody cites, if you write a paper and somebody cites you, that is also modeled by a network. Relation between authors or network. And again, why do we call them complex? It's having a very complex structure, may have so many links. Again, network is evolving. Just like our language, network is also evolving. Your Facebook friendship network or World Wide Web, everything is something that's called changing or evolving over time. And again, there may be different types of nodes in a network. For example, in a World Wide Web or in an internet, you may have servers, you may have routers, you may have ordinary machines, etc., etc., etc. So they are called complex because one, they have the structural complexity and they evolve over time and their connections are changing and there should be, there are different types of nodes. And generally, in a network, we investigate two things. One is, what are the static means non-changing property of the network and how does the network evolve over time? That's dynamic properties, behavior of the network. How does a person's friends evolve over time as he passes over various time? Or how does the link to a web page evolve over time, the network? And again, static properties may be sum of the what are the degrees of each of the nodes in a network. You are familiar with the degree of a node? Degree of a node. As number of nodes connected to it. Okay. And cuts that we have seen. And again, we may be interested in which are the most important nodes or which are the most important connections in the case. And so actually based on this, so many networks models have been evolved, and one is random network, that is there is an equal probability that every node can be connected to any other node. Then small world network and scale-free network. Small world comes from the assumption that in a network, for example, in a acquaintance network, the distance between, that's how many persons you need to get to the Prime Minister of India. Maybe 4, right? We have studied network theory somehow. So the idea is, even though there are a large number of vertices in the network, the distance between any two is on the average very small. Most of the network, there is a relatively short path between any two nodes. So generally, we said that in this world, every persons are separated by a maximum 6 or 4 other persons. So that's what we use in a network. Now we go to some more things. Centrality. Centrality is how important is a node. So I can see in this network, this node has more degree, right? But this node has less degree. But which is the most important node? Yes? May not be, because a person having more contacts need not be more influential. For example, you can see that this is having only 3 degree, but from here to here, everybody has to pass through him, right? So the importance of a person does not always depend upon the number of contacts, but also may be on so many other factors. So how many paths are through this, or here see, he's having a minimum distance from all other nodes, right? So maybe how central is this? Such things are there for determining the importance of a node in a network. So many centrality measures are there. Generally, degree centrality we have seen. Again, closeness centrality and between a centrality. Between a centrality just means how many, which is the node having more paths through it. And actually, yes, there are very so many measures to give the centrality or the importance of a node in a network. Again, another thing is identifying communities. In a network, in any network, for example, in a social network, people will be organized into communities. They will be more contacting each other etc. We have seen in that character club network, there are basically two communities. So identifying the communities, and there may be sub-communities, communities within other communities. So identifying all this is important. Community depends on the specific system. How do we define the community? Are they a set of people closer to each other, or are they a set of people who are closer to others than all others, etc., etc., etc. So basically, we get the notion that more edges between persons of the community than for example, you can say that, I can easily say in this network, suppose these are people, this is a community, this is a community, and this is a community. The idea is there should be more edges between members than from here to here, here to here. So there are links, but from here there are no links. So in network science, there are well-known strategies to identify communities. Communities can be identified among network science. So a typical example of a community is in a network. You can say that this is a community, this is a community. So based on, so I'm not going into the algorithms, but you should know that there are well-defined algorithms or methods to determine communities inside a network. So determining communities inside a network is not a problem. Another is motif. Motif is, we say that in the network, some pattern of occurs more frequently than other patterns. Some pattern occur more frequently than other pattern, then that's called a, so motif is a pattern or interconnection occurring in a graph at a number significantly higher than in a randomized versions of the graph. So you can see that these three people go together or they are interacting in a particular way than that should have been occurred randomly. Right? You must see in any network, you can see that certain patterns are occurring. If you take a class and you may find that people are moving in the groups of 3, 3, 3, 3, etc. Right? So that's a pattern. So that's called a motif. So suppose that we have 3 vertices. These all are the possible motif that can be there in between 3 vertices. Some of the possible motifs. So when you have 3, 4, etc., more and more vertices, you can define more motifs. So identifying motifs is very important in networks. Again, I'm not going into details, but also in the network science, we try dynamic phenomena, dynamic communities, how communities are evolving over time, and consensus. So for example, suppose a vote goes in a network, you can find that after some time there will be a consensus and finally it will be arriving. Another is synchronization. Synchronization is something, if you have a flock of birds flying together, you can say that they are moving in a way such that in a perfectly synchronized way. Similarly, in a network also, that if something occurs in one node, finally it synchronizes. And next is epidemics. What's an epidemics? Simple. Epidemics. Maybe a disease, maybe a virus, etc. So, how a virus or spread through a computer network, or how a disease spread through a human interaction network. So, that's important. Link prediction. So, what will be the links between two vertices, two web pages? How many links will be there for my web page in the next 5 years, etc. These are all areas. So, dynamic communities analysis is still in its infancy, because static communities finding is we have well-defined algorithms. So, but if you want to find dynamic communities, they're using the static version only. So, link prediction is finding if there is a link between two nodes, and you cannot check between, you have a 1 million network, you cannot check every time if there is a link between any two nodes. So, you have to use some probabilistic measure to predict if there will be a link between any two nodes at any time. And recent areas, interdependent networks, multidimensional networks, and network medicine. Interdependent networks are networks does not work in isolation. The one network may be dependent on another network. If one network is damaged, the flow in the other may be increasing. Can you give an example of two interdependent networks? Sure. That's a good example. Another example is you must think that they are independent, but they may not be independent. You consider the rail network and the road network. They are actually two different networks. But what happens if a rail bend is there? Flow in the road network increases. So they are interdependent. Also, the networks may be layered. And another is multi-dimensional. Means multiple connections between any pair of nodes. For example, there are two persons. They may have a teacher-student relation. They may have a brother-sister relation. They may have a relation as two persons residing inside the same campus, etc., etc. So, that's called a multi-dimensional. So, different kinds of interactions between different types of people. Okay. Again, heterogeneous networks. Some networks include vertices that's of different types. Friendship networks, people belonging to different economic scenarios. So, even though all are persons, still the network is heterogeneous. So, network medicine is one of the recent areas. It's recently a book called came in 2 years back. So, network medicine is the application of network science towards identifying, preventing, and treating diseases. I'm not again going into details because so many tools are available for visualizing networks. For example, you have Project, GAAHE, Node, Excel, Network X, also this one NetMiner graph is also Python. If you are using Python, you have a powerful network library for modeling networks. Also various and Project, GAAHE, etc. allows you to visualize networks. Node Excel is XML based. NetMiner helps you to use data mining techniques, and graph is also used to visualize networks. Have anybody used any of these tools? No. Okay. Graph is used. Now we come to our part. Language. Language can be modeled as a complex network. Once we model it, the techniques of complex networks can be applied to it. So the idea is model your language as a complex network. Language is simple or complex? Language is a complex system, no doubt. So you can try to model it using a complex network. So linguistic networks can be classified into static linguistic networks. For example, dictionaries. Suppose I say I take any word and I take all the words and connect it to a word to its synonyms. What happens? I get a network. Similarly, so that's a static network that doesn't change. Synonyms don't change, so that changes only when the language evolves. WordNet, have you used WordNet? WordNet is again an example of a static network. Now, we are more concentrating on dynamic linguistic network. Connections made on the basis of co-occurrence of words in sentences. So we connect two words. Example, consider this. John put an envelope on a table. The envelope on the table fell to the floor. The address of the envelope is wrong. Now we take these sentences and find out which are the words that co-occur in a sentence. John and put co-occur, right? Then yes, John put an envelope on the table. So he is wrong. So I connect like this, right? So this is only one of the methods of creating a network. So if you have a large test, you may be creating a very large network. So what we do is, we take a test and create the corresponding network. That's what we do. So, and we do not do simply, we use a lot of processing before doing. So consider the test. If Sally has been constantly in Bruce Carmel's thoughts since they are parted to Paris Express, Mr. Carnell had been very little in Sally's, so little indeed that she had to search for her memory for a moment before he identified. So this is just a test book, sorry, a test. So what we do a bit pre-processing of the test before starting to first pre-processing is removal of stop words and punctuation marks, and second is lemmatization. You know what's lemmatization? Root forms. Then you just, based on that, now you have this much and can easily create a network. So you have removed stop words, you have lemmatized because this if you are using a you have having 100 sentences, then words having the same root must be treated as same. So you create a network. So for any book or for any document, you can convert it into a network. And converting into a network does not always mean that they should co-occur in the same sentence. You can also say, okay, they co-occur in the same paragraph. I just connect them, right? So you can say that if they occur in the same paragraph, if words X and Y occur in the same paragraph, I give an edge between X and Y, right? Or I can say that if word X and Y occur in the same paragraph at less than a distance D, I connect them. So there are so many ways. There is not a single way to form a network from a document or text. Many extensions, extended co-occurrence. The edges are established between two words if they are separated by D or less intermediary words in the pre-processed text. Then paragraph-based model, we link and click the words belonging to the same paragraph. What's a click? All vertices are connected to all other vertices. So we say that if words are belonging to the same paragraph, all those words are connected together, and we can say that, okay, but we ignore the edges that are separated by, say, more than 10 words. So basically, you can make a network from two paragraphs based on the textual similarity between the words. So if P1 and P5 are connected, and you give a weight based on the textual similarity, because you have well-defined methods for defining the similarity between two documents. You can also connect this, and you can discard first application in languages, text summarization. And what is text summarization? Text summarization is given a text, create a summary. Automatically create a summary. So somebody working in text summarization? No. You have a text and you really want the most important points, you give the summary. So what we do is we create a text from the a network from the text, and we identify the most important vertices. We see that there are so many ways to identify most important vertices. So we identify most important vertices in 12 ways. They have identified most important vertices in 12 ways. So you just take the, if you want the summary of the text in, say, 10 words, you take the first 10 most important vertices, or in the first way. So maybe first you will be taking the vertices having maximum degree, right? So all the vertices having maximum degree. In another, you will take vertices having maximum between centrality, etc. And finally, combine all this to generate a summary. Put a word in this 12 methods, who has one, which word has one more than 6 or 7, then that word will be included in the summary. So again, this one of the another application is identify what are the topics in a text, in a document, what are the topics available. For example, I see words like cattle field, grass, maybe. etc., etc. I can see that one of the topics is about a cow, right? Maybe I may see words like marks, class, etc. But then you can see that the topic is about students. So what we do is we just have document and words and find out which words occur in which document, and based on that you create a small graph, and based on that you try to identify the document, and also you consider the frequency of each of the words. For example, you can see that 32 is appearing in document 22 times, 25 times, etc. So you can say that document contains more words about the cow, so it is more maybe speaking about cow, etc. So this is only a simple graph having only two types of vertices: document and words. So you identify which are the words which will be used for a particular topic, and you identify how each of the words are present in this. Again, we have heard of way to vec. Way to vec is you have a test and you create a vector from the text. So two texts may be having totally different meanings, may occur more frequently in the text. So you create a vector using, generally it is done using artificial neural networks. So, and you convert the document, each of the words, into a point in a vector space. That's called a weight. And if you go to Python, etc., direct functions are available to convert to weight to vec. Just need not bother about how it's converted. You can just say weight to vec and it will convert. So I must say that I have converted it into weight to vec. Then I may connect all a node to its k nearest neighbors and generate a network. So networks are not only generated from simple document, may be generated from a converted form of the document. That's called a weight to vec form. As we are talking about word sense disambiguation, what is word sense disambiguation? A word may have different senses. For example, bank may have two senses. One is a financial institution, other is bank of the river. So I want to identify, I have a test, I want to identify on in the test in which sense the word is used. So word sense disambiguation task: identify the meaning of words in a given context for specific words conveying multiple meanings. So certain words have multiple meanings. For example, match, shoot. So many meanings of words are there with multiple meanings. So identifying the correct meaning is called a word sense disambiguation. Again, this is also used. A type of network can be, you have the feature word 1 and you just identify all the features of word 1, and that word 1 is having various senses, and you identify, you make it like a network, word 1 and the senses, and how this word 1 features in the network convert to associated senses and choose a sense among that. Another is authorship attribution. What's authorship attribution? You have a text, you do not know who wrote it. It happens especially in ancient text and also modern times. If you get a letter without a name on this, anonymous letter, you may want to find, or the government may want to find who wrote the letter. This is called a authorship attribution. So typical authorship attribution problem, a text whose authorship is unknown is assigned to an author from a set of candidates. So there are different authors and yes, a set of candidates in the style of writing. Whose style is this? Yes. Their letters are there, their documents. Identify. Because this plagiarism is a totally different question, because we do not need such a thing for plagiarism, because do we need for something like this to do plagiarism? But you can identify ghostwriting. If you write your thesis, you ask somebody to write your thesis, and if he writes it, then this can be used. For plagiarism, this cannot be used. No, only if it is there. Only if it is there. Otherwise, if I do not know who wrote it, because generally no such question. I have doubt that whether this is written by him or him on his writing styles. Then only I can do this. So the procedure is identify the frequency of different motifs. I have seen what's a motif. So we identify the frequency, so make the co-occurrence matrix and identify the frequency of different motifs in the class. Also you use, you compute various things, various other properties of the network. You give it to a machine learning algorithm, and finally, because it's basically a classification problem, you have to classify who has written a text. So in short, modeling languages as networks is infancy and has lot of scope for people working in it. And I once again thank you all for patiently listening to this talk.